So we're building this model as a pilot. One thing I want to make clear is this is not a grand global model that solves every problem. This is a very policy level model of the system. Many of those relationships, as you might imagine, are things that where you don't have very precise information about the relationship. There are lots of uncertainties. So some things we can pin down pretty well. Other things are more uncertain and we have to make assumptions. So it doesn't give you precise answers to every problem. It will not let you design a wastewater treatment facility for a specific community, for example. But it will let you look at, well, if we focus on wastewater treatment, then what are some of the other implications? What if we pull back some on wastewater treatment, instead do more LID? What if we do aquaculture? What if we do this? What if we do that? Different packages of things. It'll direct us to ask the more detailed questions. It will show us where the opportunities are, where some of the things that maybe we hadn't considered before, the implications of different strategies, that would then lead us to do more detailed analysis at a finer level of more specific solutions. So it's a higher level systems model designed to pose questions and give us some feel for how the system works and what the most promising solutions might be. Then those promising solutions all need to be investigated at a much more detailed level. So then you drop down to more specific environmental models, to more place-based models. So that's kind of the structure of it. What we're trying to develop is something that doesn't exist right now, the more systems level view of things. So you can take a more holistic, broad view and identify more promising options to investigate more specifically. Going through this pretty fast, but there's going to be time for questions at the end. So what I want to do is show you what it actually looks like. So this is what you would see, and I am not a modeler. I'm a consumer of this model. I'm a customer. So as I imagine many people in this room would be, the model is designed to be used by people who are not modelers, who don't work in environmental agencies, who don't do this full time. Of course, we're all going to use it too. But it's designed that anyone who's comfortable using a computer could get onto this model and start to explore different options and get a feel for how the system works. And this is what you would see. This left-hand portion here is where you would put in different scenarios, and you can change different parameters. So for example, wastewater treatments, if you clicked on that, there'd be a tab here with all different options for wastewater treatment. In Narragansett, there are many existing wastewater treatment plants, and so what you'd see is sliders that you could move to upgrade treatment in each of those plants. So you could play around with different scenarios of do all the plants, do some of them, go all the way to the limit of technology, just go a little bit of the way. So different, you could impose different amounts of wastewater treatment. You could do different things with fertilizer. What if you ban nitrogen fertilizer? You could require that all new development be low impact development to reduce nutrient runoff. You could put in different scenarios for what's going to happen with air pollution controls to reduce nitrogen deposition. And there are other things that are going to be in here too. We're just building this model now. So this is where aquaculture would go. What if we put in aquaculture to take nutrients out of the watershed at the end? For things where we don't have solid information about a relationship, there's an assumptions tab where you can put in different assumptions. You could say the relationship between nitrogen and eelgrass acreage isn't precise. As we know, within a range, but you could make different assumptions along that range. So what if we run a scenario at one end of the range and then at the other? How much difference does it make? So it lets you play around with assumptions. So that's all. You put in different scenarios. You can change one thing, you can change a lot of things at once. You can do whatever you want to define the world you want to investigate. And then what it shows you at the end is what impact that range of interventions would have on the world. And we've divided the world up into three things. This is the three Valerie was talking about. Environmental things. And so what you're seeing here is nitrogen loading, but it's not only nitrogen that we're interested in. We're interested in a full range of environmental impacts of whatever solution we're going to adopt. So there's a few tabs up here. There are many more in the model. We're also interested in economic, and not just cost. Even that primitive, what I showed you in the first slide, had cost on it. We're always looking at cost. But what about beyond just the capital cost of a project? What about the impacts on other aspects of the economy? Different solutions are going to have different implications for things like jobs, for things like fisheries that have, and tourism that have economic impact, as well as driven by environmental things, but also economic impact. So we have a section of economic results, and we have social results. What are the changes in people's income that arguably could be economic as well? What does it mean for beach visits? And there is data. We're taking whatever data we can find on, as the water improves, what does that do to beach visits? So what are people's opportunities for recreation? How does the population change? What if you have clean water in coastal areas? Are you going to drive development into those coastal areas? And there is data on that. So we're building in those kinds of relationships. And then what you see in for each output is a 40-year projection of how that would move based on the particular solutions that we're testing out. So that's the idea. It's to be user-friendly, to give you a lot of outputs. And what you see here is red is the current. If we don't do anything, that's where we're headed. Blue is whatever intervention we chose, that's the result of that. You can plot different interventions against each other. You could say, I want to test scenario A, B, C, and D. Let's put all the lines up here and compare them. So you can do that. I'll just give you a few other pictures of how it works. So I said there are other things in the model. Here's an example. If you click on economy, there were 3 or 4 tabs on the main screen, but there's a dozen or more. If you go in, there's a little more button, so you can get other indicators here. And again, this is just the beginning. There are going to be a lot more than this. So that one is fisheries production. So I think the scenario tested here is no additional wastewater treatment. What if we just did low impact development? So you don't see much change because all we're affecting by doing low impact development is future development. We're not doing anything with the current loads. But you can see that over time it makes a little bit of difference on fisheries production. So this is several conceptual steps out in the model. The model has looked at what's the impact of LID on nitrogen loads, what's the impact of nitrogen loads on aquatic life, and what does that have to do with fisheries production. So there's a few steps that have been taken, and this is the result. Here's chlorophyll A, an environmental indicator, so you can see there's a little more of an impact on chlorophyll A. Eelgrass beds, a little bit of a change. Tourism goes up by a little bit. If you were doing more aggressive scenarios, you'd see much more difference between the no action and the impact of the solution. All right, so here's just some examples of the kinds of interventions we're looking at modeling. Some of these are in the model now, some of these are still being developed. So think conventional things like upgrading wastewater treatment plants, dealing with overflows, dealing with septic systems, low impact developments. What if we do stormwater? What if we rely on wetlands and salt marshes more for nitrogen removal? Bioharvesting is in there. So we're looking at developing a pretty robust array of things to test what their impact is. So this is the same as what you saw before about the different boxes that we're looking at. The ones in green are the interventions. So the point of this is you can intervene in a system in many different points. So if you want to address nitrogen, first thing, I've been in EPA for 20 years, so I'm kind of, my brain is sort of looks like an EPA brain. So the first thing when somebody says, well, there's too much of something in the environment, well, my brain says, well, what treatment do we need to put in to take that out? So that's in there, but there are many, many other things we can do, and there are many other points in the system that you can intervene that will address those issues. For example, people on the Cape and in Narragansett have talked about, what about something we do in the waterway to increase flow? So is there a way to build that in? So I won't dwell anymore on that. I think people get the idea. There's lots of points you can intervene, and the idea is to create a tool that lets us actually analyze that, not just think about it conceptually, but actually start to have some quantitative ways to analyze it. Okay, so now the last thing I'm going to do, as the regulator in the room, I'm going to spend a little bit of time on how do you make this work within the regulatory system. Because, and I'll go back to what I said at the beginning. We all, maybe especially us, meaning the regulatory community, need to keep reminding ourselves this is not a regulatory problem. This is not a legal problem. Those are tools that we're going to use to solve the real problem, which is what's happening in the environment. But we have to use those tools. The solution, none of us have the power to say, well, the laws don't make sense, so let's just do whatever we want. We don't have that power. It's not an EPA. Some other agencies can do it. So I'm going to talk a little bit about Clean Water Act and how we make it work, without dwelling on that too much. And for people who were in community college in September, this is a little bit of a review, but I'm going to do it much faster. So Clean Water Act has this great structure where first we say, here's what our goals are. We want safe waters, safe clean waters. Then we turn those goals into specific standards. They're usually numeric standards. Then we apply those standards to all of our waters. We go segment by segment and saying, is this water body meeting these standards? It's all very logical so far. Goals, turn the goals into standards, see where we're meeting the standards and where we have a problem. Where we have a problem, we analyze how much pollution can that water body actually absorb, so that tells us how much we need to reduce. And so now we have a reduction target, taking our broad goals all the way into specific water body reduction targets. Now we turn those into permits. We look at all the people discharging into that water body, and we say, if everybody meets this number, or if this one meets this number, and this one meets this number, it all adds up to our pollution budget, so water will be clean when we're done issuing these permits. And then we go and enforce those permits. Anybody who's not meeting their limits, we take action, we put them on a schedule, so by the end, all the water's clean. That's the idea. It's a great, great scheme. It really is. It really is. A really, really interesting talk, if we had another hour, would be to explore the gaps between every single one of these steps. So that would explain the reasons why the water is not clean. Because between each one of these steps, there's a gap. It all sounds very logical, but we lose a little bit going from here to here. We lose a little bit more going from here to here. It's really interesting how that happens. All the water, it's a great looking pail, but all the water leaks out of the little holes. But that's the idea. That's how it works. That's how it's supposed to work. Now, notice that nothing in there said anything about what do we build. We don't get to water. The statute doesn't tell us what to build. The standards don't tell us what to build. Nothing in here says build this, build that. Use composting toilets or don't use composting. That's not in here. But we get to that at the end. So this is the end. How do decisions actually get made within this structure? So I've blown up the two boxes where decisions really get made, permitting and enforcement boxes. Permitting is where we actually set the limits for specific sources. So that starts to starts to constrain the choices we can make about what we're going to do. If we say, all right, this treatment plant has got to go to the limit of technology for nitrogen removal, that's constraining the choice. That means we're not going to rely, what if there was an alternative where they didn't do that, but instead we put in composting toilets, or instead we did something else with another source? We constrained that choice by setting the permit limit. So that's one important place, is when we make choices about what we do in the permits. That's going to influence the ultimate solution. And in enforcement, that's where we actually specify what is an individual source going to do. So that's where we do talk about specific technologies and what they're going to build and how quickly they need to build it. So